James.
Thank you very much, and thanks for the opportunity to talk to you today about our work in experimental human systems to see how these can be perhaps applied to develop TBVs. So the outline of the talk, I'm going to speak a little bit about transmission in our P-falciparum system. We've been working for a number of years with medicines for malaria to investigate the activity of blood stage drugs in our system and made some observations that led to this work. Secondly, we've recently completed a series of studies with Plasmodium vivax transmission studies, and I'll go on to describe them. And then I'll finish by describing some technical challenges that we're facing and some assistance that we've had from some members of the audience and others to try and overcome those. So this is a general outline of our induced blood stage malaria studies, and it'll be presented in poster form in a late breaker session today by Shello Passay. So what we do is we infect our volunteers by giving an intravenous inoculation with, in this case, Plasmodium falciparum in well-defined red cell bank on day 0, and we follow the volunteers through the course of their study, which lasts typically for a month, with a period of confinement which coincides with the treatment with the test drug. And we ensure volunteer safety by having a real-time PCR assay that we continue to monitor the volunteers all the way through the study so that we basically are able to protect them from becoming unwell, but also, in the case of the drug, gather data on drug efficacy. Because we observed gametocytes, initially to test whether we were observing gametocytes, we developed a PCR assay that identifies messenger RNA for PFS25, and I'll show you some of that data. And we typically find that, as you see, several days after the individual receives the test antimalarial drug, the people become PFS25 positive. And then, for the purpose of transmission assays, we then are undertaking a series of mosquito feeds after the volunteers become PFS25 PCR positive, doing both direct feeds on the volunteers as well as taking blood from the volunteers and doing membrane feeding assays. And we're obviously at the end of study because we don't want to be responsible for a malaria epidemic. We're ensuring our volunteers leave the study having been given a course of Primaquine. So when we first began to make these observations, we first discovered initially to our concern that with some of our drug studies we were seeing volunteers remain PCR positive after the test drug. And we would then treat these volunteers with a second course of coartem artemether lumefantrine, and the PCR would remain persistently positive. And that was obviously of some concern to us, in that was what was going on. But on reflection and on further work, it became clear to us that these people who remained PCR positive for basically genomic DNA of the parasite were in fact carrying gametocytes. If we do not treat these individuals and leave them, we do notice that the parasitemia does not increase exponentially. And that's in contrast to some of the studies where we have a failed drug, and I'll show you an example of that in a moment, where the parasitemia does increase exponentially, so there still is obviously asexual replication of the parasites. And I've already said that this is refractory to treatment with a drug that's active against blood stage activity. We've gone on now and proven that these people are gametocytemic by using flow cytometry, using an assay that we've developed in-house. We've also identified gametocytes by other traditional means of a thick smear, as well as concentrating by magnetic bead concentration. And then, as I said before, we've also developed a PFS25 PCR marker. So this is the typical course of one of our studies we undertook last year. This is with the antimalarial drug piperoquine, which is a part of the co-formulation for uartisum. And we're asked by Medicines for Malaria to look at the activity of this drug alone in terms of its ability to kill parasites. And this will be presented in poster form on Wednesday. So what you see here is the volunteers become parasitemic in the typically logarithmically increasing phase up to when they reach their treatment threshold. They're given a dose of piperoquine, which actually turns out to be a very active antimalarial drug when given alone against 3D7, and they rapidly clear their asexual parasites from their blood. Now, this was done in 3 dose cohorts, and I won't go into it for interest of time today, but in some of the volunteers we see this persistent level of low-level positivity PCR, and these are parasites per mil. So between 100 and 1,000 parasites per mil, we're seeing this low-level PCR positivity. We What we have also done is to prove that this is really gametocytes is treat these people with primaquine. And as you know, primaquine kills gametocytes, and I won't go into it, but we were able to randomise volunteers to 3 different doses of primaquine, and individuals with no primaquine until end of study actually remained persistently PFS 25 positive for over 3 weeks. But if we gave primaquine, it rapidly terminated their transcriptemia, which also obviously as a surrogate marker for them being gametocytemic. So here we think we had a system where we've made our volunteers potentially infectious to mosquitoes. The question is, can you use this as a model system to, for example, study a transmission blocking vaccine in a phase 1/2A system? And here's just some other data of a typical gametocyte seen on thick smear, and the flow cytometry that Chris Peaty from the Australian Army Malaria Institute has developed, where we can segregate male from female gametocytes by fax. So what about Plasmodium vivax? Well, those of you who are familiar with PV will know that gametocytemia appears very soon after the appearance of asexuals in Plasmodium vivax. So people with vivax are infectious right out of the gate. And certainly people with Plasmodium vivax, just like in P. falciparum, can transmit to mosquitoes very early in infection, and work done by Bill Collins, and which will be remembered in a symposium later this morning, was critical to some of this, and here are some of the references from that. So Plasmodium vivax is obviously an attractive opportunity, and because we have developed a blood stage vivax system, we were asked by PathMVI to see whether we could identify develop this as a system to study transmission to mosquito. So our vivax study looked very much like the falciparum studies. This will be presented by Paul Griffin in a poster on Wednesday, and Paul won the Elsevier Clinical Research Award that was announced last night based upon this work. So here we have our volunteers who are basically followed for a period of a month. Because our Plasmodium vivax bank, or at least this bank, is has much fewer parasites, we have a prolonged period of negative PCR positivity, and people become PCR positive on about day 8 in this system. So we are, and because people become symptomatic very quickly, more quickly than certainly in falciparum, we have a relatively narrow window in which to do membrane feeding assays and obviously study for gametocytes, and we have a confinement period in our inpatient facility during this. So this study entitled AVITA, which stands for Experimental Vivax Transmission to Anopheles, had a total of 3 cohorts. We had 2 subjects in each cohort. They were inoculated with 100 Vivax-infected red cells on day 0. Rescue treatment was with artemether-lumefantrine, and treatment thresholds were when symptoms develop or when they reach their PCR target. We were able to do 3 days of transmission studies from the humans to the mosquitoes, both by the standard indirect feed, as well as our volunteers were successfully able to undertake 3 direct feeds, where we took 30 mosquitoes for 10 to 15 minutes 3 times directly on the skin. And our measurements for transmissibility were obviously our PFS 25 PCR, but also hopefully to look for oocysts in the midgut of the mosquitoes. So first, going over the parasitemia data. This data is very hot off the press. We only finished the 3rd cohort last week, and we have 3 cohorts in red, blue and green. And what is really interesting for me for a clinical trial is how reproducible this is. When each time we do this, we seem to see very reproducible growth in parasitemia up to our target level when they receive treatment, and then they very rapidly clear their parasites after being given rescue treatment. Our PFS 25 data, I only have two groups shown on this, but the 3rd group actually is identical in shape. We only got the data on Friday from the RNA PCRs, and you can see that people become PCR positive for PVS 25 about 2 days after they become positive by genomic PCR, and their gametocytemia, as determined by PCR, rapidly clears in cohort with the standard parasitemia marker. So we obviously, I've been over this, and our transmission studies are obviously whether we can see oocysts in the midgut and then hopefully salivary gland sporozoites. and this has been where we've got to in the last 12 months has been a difficulty in terms of getting from here to here because of a range of issues that we faced reflecting in some part our inexperience in doing these assays. So here's a picture of a midgut from one of our AVITA cohorts, and you can see these structures here, which we initially thought were oocysts, but the comment from the external expert was that these were abnormal-looking oocysts, i.e. they may not be actually oocysts at all, or they may be oocysts that don't are not transmissible to mosquitoes. But unless you're an expert in doing these things, and we'd never done this before, we felt that they looked pretty good. So this is from our piperacin study. So this is P. falciparum, and we saw these circular structures in the midgut of our mosquitoes, and our external expert said these weren't oocysts. So we had definitive advice that these weren't. And then a third expert looked at one of our cohorts and said that she thought this was an oocyst. So clearly we need to work closely with people like Tune to improve our systems to actually determine which and is not a malaria oocyst in the midgut of the mosquito, because we've got all the pieces of the puzzle in place up until when we are actually able to get to this stage. So that remains brings up a number of questions related to this. So first of all, in our P. falciparum system, the density of our gametocytemia is quite low. It's at the limit of detection by thick film. So we really don't know whether that's going to be sufficient to develop a system where, for example, you would be able to test a transmission blocking vaccine in our clinic. Then the second question is really, have our gametocytes been damaged by our piperacin treatment? And that's something we're working on at the moment, that perhaps they may be present but somehow unable to mate and form an oocyst in the gut of the mosquito. And certainly there are precedents for that in the literature, that both SP and tafenoquine in a rodent model appear to be sporonticidal even if they're not gametocidal. So that's a technical issue which we believe that we can solve, but it's one that we need to address before we beat ourselves up anymore about not being able to find oocysts in the midguts of the mosquitoes. So in terms of learnings from these studies, we've made a lot of progress in the 12 months that we've been doing this from when we initially made the observation. So our first learning is to thank all of our teachers, many of whom are in the audience, because I'd never ever considered myself to be a malaria transmission biologist, and we've really learned a lot about what we're doing in this last 12 months through support of MVI. And I think with the Plasmodium falciparum system in particular, these have been built on the back of drug studies, and in order to make good progress like we did with the AVITA Plasmodium vivax study, we really need to undertake studies which are purpose designed to study transmission rather than a sort of add-on to a drug study, because it's such an important question, and then there will be different ways that we would undertake the clinical trial if we are wanting to really optimize the system to study transmission in Plasmodium falciparum, which is obviously a higher priority for a transmission blocking vaccine. So just quickly in discussion, is the gametocytemia in these experimental systems high enough to reliably transmit infection? And that, I think, remains an unanswered question. And then obviously we're looking to make technical improvements in our system to actually get to a point where if the answer to this question is yes, can we develop a robust system that will be able to take a vaccine candidate from phase 1 into an pilot efficacy study in a human clinical trial environment before going to the field to do the large scale assay clinical studies that we needed for the work. So finally, I need to acknowledge all the people involved. I do apologise that the PathMVI logo got dropped off in Mac to PC, but you'll have to say that the AVITA study was funded by PathMVI. Medicines for Malaria funded all the Plasmodium falciparum work. I need to give a big thank to our volunteers, because these people remain in study for a month. Then they get malaria, and then they get fed on mosquitoes. So we really ask a lot of things from our volunteers. In my laboratory, Silvana Sekulowski, Catherine Trenholm, and Shello Passay have been critical to these work. And then I collaborate very closely with the mosquito control laboratory, which is down the hallway from myself. I've had great support to develop all these experimental PCR assays that have been able to do the work, working closely with Chris Petty at the Australian Army, Dennis Shanks for medical monitoring, All of our clinical trials are undertaken at Q Farm, and Paul Griffin is the principal physician at Q Farm. As I say, Medicines from All Air and Path MBI, thanking Jorg in particular for his support for this, and Chris and Karen for project managing us. And then there's a long list of people that have been our teachers in terms of helping us with our mosquito transmission study. Jetsamon spent a week in our laboratory last week helping us with our third cohort. Andrew has been very helpful with technical assistance. Lisa Ranford-Cartwright from Glasgow and Maureen Cortese from South Africa have all helped us enormously, as well as Megan Dowler and others from Walter Reed. So I'd really like to thank all those people who've given us support so that we've got to this point now. Thank you very much.